Today we will price European options, including both call and put in C++ using the Black-Scholes formulas. Let's quickly discuss a few things before we start the implementation. The first one is about namespace. You probably already noticed that in the first program, hello.cpp, we have used the outstream library and the cout object, which does not have the std in front, while in the second program, basic.cpp, we also use the outstream library, and here the two objects cin and cout, they have the std in front, which is followed by the scope resolution operator and then the object. So why they are different? It is clearly due to this statement. Namespace is introduced in C++ to solve one of the problems in C language. That is, you'll run out of names for functions and variables. Functions and variables in different libraries can be wrapped up in their corresponding namespace to avoid this collision. Say there's another library which also implements its own version of string. That is absolutely fine as long as it is defined in another namespace and we can tell which is which. So you may ask when we should use this statement. Is it preferred to use it or not to use it? Personally, I would prefer not to use this statement. I always put std in front as it clearly tells that if you're using something that is provided by the standard C++ library. But it is okay to use the statement using namespace std if you are using the standard libraries only, or if you're pretty sure that there's no name collision when you're using multiple libraries. The second thing is about the Black-Scholes formula. Sometimes it is also called the Black-Scholes-Merton formula. It is named after these three gentlemen, Fisher-Black, Myron Scholes, and Robert Merton. In 1973, Black and Scholes published their paper to introduce their model to the world. In the same year, Merton really took what Black-Scholes did to the next level by giving modern interpretations of the Black-Scholes formula. All of them would have won the Nobel Prize in economics in 1997, but unfortunately, Fisher-Black passed away in 1995, 2 years before the award is given to Myron Scholes and Robert Merton. To price the European call and put using the Black-Scholes formula, we need to input 5 different parameters. The first parameter is the current asset price, which is the S0 here in the formula. The second parameter is strike price, which is the K in formula. And the third one is risk-free rate, which corresponds to R. And the fourth parameter is volatility of the underlying asset, which is also the standard deviation of the logarithm for the underlying asset, which is sigma in the formula. And then the last one is expiry, or how long do I need to hold the contract for in years, and that corresponding to the capital T in the formula. All these 5 parameters will be defined as double. This time we can see we didn't initialize these variables when we define them. That is fine because we know that we're going to get their inputs from the console immediately after we define them. For the computation of D1 and D2, it is pretty straightforward, but we need to use 2 functions defined in CMass. So these two functions are the log and the sqrt, which is for square root. After the computation of d1 and d2 is done, then it is the tricky part. We need to calculate nd1 and nd2. Here the capital N refers to the CDF, or the cumulative distribution function of a standard normal distribution. And unfortunately, C++ does not define CDF functions directly. If we go through the available functions that is defined within the CMath library on the website CPP reference, we will find a function called ERFC. Let's click on this one. And in the example of ERFC, the error function, we will see the defined function which converts the function ERFC to the CDF. Let's trust them. For now, we can view this function normal CDF as a black box. That is, you throw one parameter with the type double into this function, and it will do some calculation, return the results with the double back to you. Then we can easily call the normal CDF to calculate the value for ND1 and ND2. Notice that if we need to calculate the price for the put option, we also need to calculate N minus D2 and N minus D1. Do we need to call normal CDF 2 more times to get these two values? Actually, we don't. If you are familiar with normal distribution, you will know that the PDF of normal distribution is symmetric. Hence, this equation will hold. And then we can easily calculate this value by 1 minus ND2 and this value by 1 minus ND1. The remaining part is pretty straightforward, as what we need to do is simply turn the mathematical formulas into the C++ expressions. Let's click and run this program. Now let's input the 5 parameters using the values given. Okay, great. Now we get the values for the call option and the put options. These parameter values actually come from an example in the book, options, futures, and other derivatives. So these two values will match the values in the book. That's pretty everything for the video today. Thanks for watching.